surface area. We're gonna figure out how to solve surface area. Now, surface area figure is it's the summation of all the area of all the flat sides, all the faces. So here, like in this pyramid here, 4 faces around form the pyramid, and then the base. And the way you generally find surface area is area of the base, or bases, depending on how many bases you have, plus perimeter of the base times the height. So that's the way you generally find surface area. It's like for this one right here. We're going to find the area of the space right here. Well, that's easy for us. It's a rectangle. It's a square. Sorry. It's a square. You can see by the tick marks. So they're all 13.2. So my area of my base is going to be 13.2 squared. I'll plug that into a calculator later. Now, next thing we need to do is we need to add the perimeter of the base. I'm going to times that by the height. Now, we'll talk about what the height is here in a second. First, the perimeter of the base. When I say that, I mean this. Right, we're going to find the perimeter of this base here. And then we're going to times it by the height. Now, the height of this face here is not the height that they give us 10.8. 10.8. That's the height of the whole figure. But I need the height of the face, which would actually be this guy. Right, I need the height of the triangle I'm talking about. So we're going to find the perimeter of the base, we're times it by the height, and that'll give us area for all the sides of faces. Now the way we find the height is, well, we make a right triangle here. I know this full length here is 13.2. Well, my perimeter, by the way, my perimeter here will be 13.2 plus 13.2 plus 13.2, or 13.2 times 4. And my height, I gotta figure it out by using the Pythagorean theorem. Now the height we know is 10.8 because they told us right here. So let me draw the triangle out here. It's a little easier for us to see. Right, we're looking for this guy. This is 10.8 because they let us know. The base right here, that we know the whole base is 13.2. So if we divide that by 2, we get like 6.6. So all I gotta do is find the slant height here, and I can plug into there, and then we have the whole perimeter. Right, because all the perimeter is area of the base, so I'll get to the bottom face. And to get the 4 faces around, it's just the perimeter of the base times the height. So we're just looking for the height of this. Looking for the height of that triangle there. Anyway, so we're going to use the calculator for this. It's going to be 10.8 squared A plus 6.6 squared equals L squared. Right? A squared plus B squared equals C squared. Let's bring over a calculator. So 10.8 squared plus 6.6 squared. And then we're going to take the square root of that. And I get something like that. So my length is 12.657, blah, 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 blah. Now, I'm going to leave my answer like this. So in IB, they want you to use 3 sig figs, which in this case would be 12.7. But the key about 3 sig figs is you only do that when you have an answer, like when you're solving a problem or a portion of the problem. So right now, I'm not solving any question here. So I'm still working on my problem, so I want to keep my answer as full as possible for now. So right here, I will write 12.657, but when I multiply it all together, I will use the value from the calculator. So I have that. So it means my surface area is just, let's simplify all this. So it's going to be this guy times the perimeter, which is, right, because that's the side height, and multiply that by the perimeter, which is 13.2 times 4, because there's 4 sides. I just add them all up, so 13.2 times 4 is the easiest way to do that. Then we're going to add the area of the base there, which is 13.2 squared, because it's, even though it looks like a rectangle, it is a square. I mean, all squares are rectangle, but you know what I mean. All rectangles are, yeah. Oops. Like this. And we get our answer. So here I'll put 3 sig figs. 842.53. 3 sig figs would be 843. So like that. And that's the surface area. Let's do the surface area of this one. And we're going to do the same way. We're going to find the area of the base. In this case, since it's a prism, it's a triangular prism, not a rectangular prism. there's actually two bases. There's a base in the back and a base in the front. The base is always a parallel side. Things are parallel to each other. So in this case, my base is this guy. And that triangle back there. So those are my bases. So since the prism, I'm going to do 2 times the area of the base because there's 2 of them. Plus the perimeter of the base times the height. Now, if this is my base, I could probably find the perimeter right now, right? I have all sides of the triangle. It's 10 right here, 6 is this, and I don't have the hypotenuse. I guess I don't have it yet. So this is 10, this is 6, I gotta figure out what this side right here is. So to do that, a squared b squared, a squared plus b squared equals c squared. Remember, c is always the hypotenuse, so I don't know what that is, so 10 squared plus 6 squared equals c squared. I get 100 plus 36 equals c squared. 136 equals c squared, and square root that, that's some ugly decimal, so I'm just going to leave it as radical 136 for now. So that's my height, so that makes my perimeter, the perimeter of my base right here is this guy times, add up all these sides, right? This side plus this side plus this side. So my perimeter is going to be 10 plus 6 plus rad 136, which I'll simplify later in a calculator. Now the height, I'm talking about if this is your base, the height is the thing that's perpendicular to it. So that would be 12, right? So if you like lay it on its side, this is the base, the height should be 12 right here. So there we go. All we need to do now, since we have the perimeter of the base times the height, we got all the side right there, is find the area of the base and times it by 2. Now in this case it's a triangle. It's a right triangle, which makes our life easier. Area of a right triangle is 1/2 base times height. And the key thing here is the base and the height are always the things with the right angle. So this is the base and that's the height. So this is 10 and 6. So 1/2, 10 times 6, so 30. And we're going to times it by 2, so we get 60 again. So it's 60 plus whatever this mess is. I'm just use the calculator. So plus 10, oops. Right, I'm going to multiply all this by 12, so I'm going to go 10 plus 6 plus radical 136. Now if they wanted us to put in a certain form, like if they said the answer was like 3 plus rad 2 or something like that, they don't have to break it down. But I think most of this case here, they just want to use a calculator. So I get this. I should have not put the 60 plus, just so I could fill out this part correctly. So this would be 331.94, and then add them together, I get 391.94. 3 sig figs, 392 meters squared. It's squared because it's area. Area is always squared. So there we go. Next one, a Taylor prism, which is just this regular hexagonal prism made of clay. Well, it's normally made of clay. That's what a Taylor prism is. That, I mean, little history there. That doesn't matter. What matters is we're trying to find the surface area. What's the total surface area of this thing? And again, surface area, especially for a prism, is since the prism, that means we're going to have 2 faces here and here, right? The parallel sides of the faces is 2 times the area of the base plus the perimeter of the base times the height. Alright, so let's talk about the perimeter of the base first. I think that's usually a little easier. I changed my color because this thing's orange. Perimeter, that's hard to see. Perimeter of the base is this guy. Right, and then the height would be 38. So I already have the height down. 38 centimeters. The perimeter of the space, well, it is a regular hexagon, so it has 6 sides. There it is, regular hexagon. So it's 8.5, which is all this times 6. And there's my perimeter of my base, 51. So all I got to do now is find the area of the base, and that's the harder part. Now they do give a hint. A regular hexagon can be divided into 6 equilateral triangles. So if we look up here, you could divide it into 6 equilateral triangles. That is not what I wanted to do. There we go. Kind of like this is what they're talking about. Or if you look at one of them, this base here is 8.5, and the height, right, I erased over it, but the whole thing from this side to this side is 14.7. Well, if you saw the way I cut in half, that's just half of the height, right? So if the whole thing from here to here is 14.7, the height of one of these triangles is just 14.7 divided by 2. which is 14.35, 7.35. Let me make sure. 7.35, so that's the height. Right, so if we want to find the area of this one little triangle right here, we're just going to do 1/2 base times height, and we have the base, 8.5, and we have the height, 7.35. This is definitely a calculator problem, so let's type that in. 0.5 times 8.5 times 7.35, and I get 31.2375. Now that's the area of one triangle, of just the one. But we have 6, it's a regular hexagon, we have 6 of them, so we're going to multiply this by 6 to get the whole base. And after we multiply by 6, we got to multiply by 2 because we got to get both of them, top and bottom. So I get my base, that's me all this, which would be, times this by 6, 187.425. Now remember, I am not doing 3 sig figs till I get an answer at the very end. And then if I have to use that answer later on, I could use it, but for now, you don't want to lose any of the actual values you have. So I got that, and just going to plug it into my calculator. So I'm going to times this by 2, and add 51 times 38. And our surface area is 2312.85. Now, honestly, IB usually lets that go if you just leave it as an answer. They also allow you to, so that would be fine. If you want to do 3 sig figs, it would be 2310. They accept that also, but they usually, when they do sig figs, it's usually when you have like long decimals. That's what they care about. Not when you have like something like this. Okay, so we talked about prisms. Let's talk about different types of surfaces. So these are curved surfaces. And for most of them, it's the same idea. If you do a cylinder, it's the same idea. You want to do area of the base, which in these cases is these two circles. So that's where this comes from. That's where this comes in, right? Pi r squared is every circle. There's 2 pi r squared. And then how do you find like the lateral height? Well, it's perimeter of the base times the height. When you have a circle, the perimeter base is called a circumference, so 2 pi r, and then you times it by the height. That's where this formula comes in. I believe this is in your formula sheet, but that's where it comes from, right? It's this area of the base plus the sine height, horizontal height. If you have a sphere, it's just this formula, area equals 4 pi r squared, easy enough. If you have a cone, it's still the same idea, right? Area of the base, now there's only one base this time because it's a cone, so that's where the pi r squared comes from. And then it's the same idea. Perimeter, which in a circle is circumference, so 2 pi r, times the sine height. Now, they actually went through all the math, and sine height is just s, so this is actually an easier formula. You don't have to go through the math yourself. They just give you the formula. So that's nice. I like that. Okay, let's do an example or two. Find a 1 decimal place, the outer surface of the area. Now, like I said, we mostly do 3 sig figs, but if they want to 1 decimal place, you follow what they say. Do 1 decimal place. So if I want the surface area of this, is just 2 pi r h plus 2 pi r squared, right? Area of the bases times, there's 2 bases, so this comes from, and then perimeter of the base, which is circumference, times the height. That's all it is. Now in this case, my radius is 6, so they just gave us a radius, so I'm literally just plugging and chugging. Okay, I'll probably simplify this by hand. That's a 15, so maybe not. So let's see. Let me keep it in pi. What's this? 6 times 15, so that's 60 plus 30, so 90 times 2 is 180 pi. It's 36 times 2, so 72 pi. And 252 pi. So if you want to keep it in pi, it says 252 pi. If you want to put in your calculator, feel free to put in your calculator. Next one, it's a sphere, so we just have a formula for that. If you want the surface area, it is 4 pi r squared. Again, I believe that is in your formula sheet. So you just plug it in. 4 times pi times 8 squared. So 64 times 4, 16, 133, 136 pi. Hope that's right. I've been wrong in the past. And then the cone one, which again, lucky for us, they just get the formula because it's a lot easier than having to find the triangle. Oh, they just give us the height anyway. So I guess it doesn't matter. Right? So it's the area of the base, which is pi r squared. That gets you this guy. plus perimeter of the base, which is circumference, 2 pi r, times the height, which in this case is a slant height, which in this case is 12. That's my radius is 5, so there we go. So this will give me 60 times 2 is 120 pi, plus 25 pi, so 175 pi. 145 pi. And there we go. That's the lesson.